This is a solution to problem 117 from homework 1.4 day 4. And this is a problem where we're going to use the position equation. So the problem states you throw a baseball straight up into the air at a velocity of 45 feet per second. You release the ball at a height of 5.5 feet and catch it when it falls back to a height of 6 feet. So the position equation is given to us, and it's that the height at any given time t is given by the equation negative 16t squared plus v naught t plus s naught. Remember, v naught is the initial velocity, S naught is the initial height. So if we look back at the problem description, V naught is the initial velocity, which is here. So V naught is 45 feet per second. And the initial height is where you release the ball, which is 5.5 feet. That's going to be S naught. So the height equation at any time t is going to be negative 16t squared plus v naught, which is 45t initial velocity, plus s naught, which is 5.5. That's the answer to part A. Part B says, what is the height after a half a second, 0.5 seconds? So in order to calculate that, we can use the function from part A, which is going to give us the height at any time t. So h of t is going to be equal to negative 16 times 0.5 squared plus 45 times 0.5 plus 5.5. And this would be a calculator problem if you enter this all into the calculator. I mean, I can simplify a little bit. It would be negative 16 times 0.25 plus 45 halves plus 5.5, which would give us negative 4 plus 22.5 plus 5.5. So I guess we don't really need a calculator for this. We can do this ourselves. This will turn out to be 24 feet. So the height is 24 feet after 0.5 seconds. Part C says, how many seconds is the ball in the air? So in order to calculate that, we need to figure out when the ball is caught. And so we're told that the ball is caught at a height of 6 feet. So in this case, the ball isn't falling to the ground. So we're not trying to calculate when the height is 0. Instead, we're trying to figure out the time when the height is 6 feet. So we're going to set h of t is equal to 6, and then we'll go back to our original equation, which is negative 16t squared plus 45t plus 5.5. And now this is the quadratic equation that we need to solve. So in order to do that, we want to set one side of the equation to 0. So I'm going to subtract 6 from both sides of the equation, and then I'll have 0 equals 16t squared plus 45t minus 0.5. And then for this problem, I would most likely use quadratic formula because it doesn't look like it's going to be something that we can factor. I don't want to complete the square when the leading coefficient is negative 16. So I'm going to use the quadratic formula. And so I'm going to start doing that now. So we're going to say a negative b, so negative 45 plus or minus the square root of b squared. So that's 45 squared minus 4 times a, which is negative 16, times c, which is negative 0.5, all over 2a, which is 2 times negative 16. And if we begin to simplify this, we can enter these things into our calculator. We get negative 45 plus or minus the square root of 1993. That's what 45 squared minus 4 times negative 16 times negative 0.5 is, all over 2 times negative 16, which is negative 32. And if we enter this in our calculator, we'll get two values, negative 0.11 or 2.8 seconds. The 0.11 doesn't make sense. There's no negative time. So the ball is in the air for 2.8 seconds. That's when it's caught at 6 feet. So the ball is in the air for 2.8 seconds.